Hello, and welcome to another TA Tech Tip. In this Tech Tip, we will demonstrate how to set up the TAM IV to optimize baseline performance when large ambient temperature fluctuations are present. The Macrocalorimeter with an accessible reference and the 20 ml Mini-calorimeter with a fixed reference have a stacked design, meaning the reference sits below the sample measuring cup. Because of this, if there are large ambient temperature fluctuations, the effects seen by the sample are different than the reference. To adjust for this effect, we will need to calculate and enable the filter time constant and heat flow dependency values. The filter time constant represents the thermal connection between the ambient temperature and the calorimeter measuring cup, and the heat flow dependency is the shift in baseline value per degree Celsius of ambient temperature change. Keep in mind, these values will be different for different configurations. To get started, you will want to set up your lifter and sample holder configuration. The Macrocalorimeter has an accessible reference which is already in place. For instructions on changing the reference, please refer to the Getting Started guide. On the lifter, loosen the locking collar and pull the rod upward and retighten the locking collar. As a measure of precaution, use the clamp and secure the rod to prevent any slipping during the equilibration period. Lower the assembly into the equilibration position for at least 30 minutes for the Macrocalorimeter. Depending on the set temperature of the thermostat, you might want to temporarily disable the watchdog during the loading process. If you are using the 20 ml Mini-calorimeter, you should equilibrate for at least 15 minutes using the built-in magnet. After the equilibration period is complete, lower the sample holder into the measuring position and let the calorimeter signal stabilize. This will take at least 45 minutes. To do this, loosen the clamp and the locking collar and lower the rod down. Do this carefully as you don't want the sample to drop down and damage the calorimeter. Once the sample is lowered all the way, you will feel a firm resistance. This is the lifter hitting the top of the sample holder. To avoid thermal contact, raise the rod around 4 to 6 millimeters and secure the locking collar. While the system is equilibrating, we can verify a few things in the software. Maximize the calorimeter window for full control. Click Maximize for Control, found in the upper right corner. Next, we will change the user level, which can be done by clicking on Settings, User Information, User Level, and selecting Advanced. Click OK. Now we will want to make sure the heat flow correction is disabled to get a true representation of how the ambient temperature fluctuations are affecting the heat flow signal due to the nature of the stacked measuring cup and reference design of the calorimeter. To do this, click Advanced Settings, Calorimeter Settings. There is a box at the bottom of this window that you will want to make sure is deselected. If it is selected, simply click the box to deselect and then press the arrow in the middle to enable the change. Once the signal has stabilized, it is time to run a gain calibration. This can be done in two ways, either through the battery gain calibration experiment wizard if working with a wired system. The wired system would also have a calibration heater lowered in the sample holder. Or you can do this through the devices window using the built-in heaters of the calorimeter. Following the gain calibration, leave the lifter and sample holder in place and start an ampule experiment, and follow the prompts in the wizard. With the sample already being loaded, you can just click through this part of the process. Do not disrupt the system and collect a few days of baseline signal. In this tech tip, we learned how to set up the TAM IV to collect the data needed to calculate the filter time constant and heat flow dependency factor. Please stay tuned for more helpful tips from TA Instruments, and thank you for your interest.